Hello, good morning, students. Today we are going to do exercise 10.5. Question number 1. Find the scalar triple product of three vectors ABC if vector A equal to I minus 2j plus 3k, B equal to 2i minus 3j plus k, and vector C equal to 3i plus j minus 2k. So scalar triple product of three vectors is given by the value of this determinant. The first row of the determinant will be the scalar components of the first vector. The scalar component of the first vector are 1, minus 2, 3. So the first row will be 1, minus 2, 3. Second vector is B here. So scalar component of B are 2, minus 3, 1. So second row will be 2, minus 3, 1. And the third vector is C. Scalar component of vector C are 3, 1, minus 2. So the third row will be 3, 1, minus 2. Now we have to expand the determinant. We'll expand it along the first row. Then it will be 1 into minus 3 into minus 2 is 6. Minus, this is permanent minus sign, minus 1 into 1 is 1. Minus 2 whole into 2 into minus 2 is minus 4. Minus 3 into 1 is 3. Plus 3 into 2 into 1 is 2. Minus 3 into minus 3 is minus 9. So minus minus will become plus 9. 6 minus 1 is 5. Minus become plus 2. Minus 4 minus 3 is minus 7. Plus 3 into 2 plus 9, 11. And then we have simplified it. We have got 24. So scalar triple product of A, B, C is 24. The scalar triple product is always a real number. It's a scalar quantity. Question number 2. So that the vectors A, B, and C are coplanar. The vectors A, B, C will be coplanar if the scalar triple product of the three vectors A, B, C is 0. So we'll find the scalar triple product of the three vectors. The first row will be the scalar component of the first vector. The scalar components are 1, minus 2, 3. Second vector is B. The scalar components of B are minus 2, 3, minus 4. Third vector is C and its scalar component 1, minus 3, 5. So the first row will be 1, minus 2, 3. Second row minus 2, 3, 4, minus 2, 3, 4, and third row 1, minus 3, 5. Now you expand the determinant along the first row. 1 whole into 3 into 5 is 15. Minus 3 into minus 4 is 12. So minus 12. Minus, this is permanent minus sign. Minus 2 whole into minus 2 into 5, minus 10. Minus 1 into minus 4 is minus 4. Minus become plus 4. This is plus always. Plus 3 whole into minus 2 into minus 3 is 6. Minus 1 into 3, 3. And then we have simplified this. We have got 0. Since the scalar triple product of the three vectors is 0, so the volume of the parallelepiped formed by these three vectors is 0. So the vectors will lie on the same plane because the volume is 0. That is, the vectors are coplanar. So A, B, C are coplanar. Next, question number 3. Find lambda if the vectors I minus j plus k, 3i plus j plus 2k and I plus lambda j minus 3k are coplanar. So the first vector you denote by factor a, second vector is b suppose, and the third vector is denoted by c. Given that the vectors are coplanar, you find the value of lambda. Since a, b and c are coplanar, therefore the scalar triple product of the three vectors will be 0. The first vector is a here, so the scalar components of the vector a are 1, minus 1, 1. Second vector is b, scalar components are 3, 1, 2, 3, 1, 2. Third vector is c, and its scalar components are 1, lambda, minus 3. Now you expand the determinant along the first row. 1 whole into 1 into minus 3 is minus 3, minus lambda into 2, 2 lambda, minus, this is permanent minus sign, minus 1 whole into 3 into minus 3 is minus 9, minus 1 into 2 is 2, plus 1 whole into 3 into lambda, 3 lambda, minus 1 into 1, 1, equal to 0. Now we have to solve this equation. Minus 3 minus 2 lambda plus minus 11 plus 3 lambda minus 1 equal to 0. Plus 3 lambda minus 2 lambda is lambda. Minus 3 minus 11 is minus 14. Minus 14 minus 1 is minus 15 equal to 0. So lambda equal to 15. So this is the value of lambda. Next, question number 4. Let vector a be I plus j plus k, b equal to I and c equal to c1i plus c2j plus c3k. Then if c1 equal to 1 and c2 equal to 2, find c3, which makes a, b, c are coplanar. We have three vectors a, b and c. Given that the vectors are coplanar, you have to find the value of c3. The value of c1 and c2 given. Value of c1 and c2 given in the question number a. Since a, b, c are coplanar, so the scalar triple product will be 0. First vector is a, so the first row of the determinant will be 1, 1, 1. The scalar components of the vector a, 1, 1, 1. Second vector is b, and the scalar components of vector b, b is vector I. So its scalar components 1, 0, 0. Scalar components vector b is I, so its scalar components will be 1, 0, 0. So the second row will be 1, 0, 0. Third row, vector c, third vector is c, so third row will be c1, c2, c3. c1, c2, c3. Now the value of c1 and c2 given. The value of c1 is 1, value of c2 is 2. You have to calculate the value of c3. So substituting value of c1 and c2 here. Now we'll expand the determinant. 1 whole into 0 into C3 is 0, minus 2 into 0 is 0, minus 1 whole into 1 into C3 is C3, minus 1 into 0 is 0, plus 1 whole into 1 into 2 is 2, minus 1 into 0 is 0, is equal to 0. So this implies 0 minus C3 plus 2 equal to 0. So this implies minus C3 equal to minus 2, C3 equal to 2. So this is the value of C3. The remaining questions we'll do in the next class, okay? And this exercise is very important. You have to study nicely, because from this exercise every year 1 4 marks question comes in the final exam, okay?